Mhm. Mhm. Sure. Chemistry methods. That's not true. Okay. Hello, everyone. If you are on the call, please can you send an emoji, um, just the reactions. Let's know that you guys are here. I'll stick around for a couple of minutes. We are still expecting more people to join. All right. All right, guys. I think we are just going to get started. Good evening, everyone. Welcome to today's workshop. My name is Noibi Abdulrazak, and I'm the um, cloud captain of this club, that's AWS Cloud Club Junior Lag. And today we are going to be looking into networking. Um, Wherever you are, this is going to be an interesting um, topic that we're going to be treating. And I'm going to tell you for a fact that this is one of the fundamentals of tech in general. And then we are going to be talking about networking, the VPC, the components, the route tables, and all of that. So it's going to be full packed. You're not just going to come and learn the probably just talk about the theory aspects, and there will also be workshop. So this you don't want to miss this. Stay tuned while we get uh, the the trainers on board. All right. And for if you are here and you have a friend that's supposed to be here and they are not here, you can reach out to them to join the call as well. Send a message to them. Don't learn alone. You know, get other people to join the call. So this is going to be interesting. And yeah. So I'm going to be inviting our trainer for today's session. His name is Mohammed. So Mohammed is going to be walking us through the the VPC stuff, the networking stuff, and is the co-assistant of the tech lead in the AWS Slack Club Unilag. Um, so yeah, it's going to be amazing. You're going to enjoy him. Please stay with us while he walks us through the process. All right. Um, yep, Mr. Mohammed, you have the
Hey,
floor.
good evening, everyone. Good evening. Okay, am I audible?
Can
Can
hear you.
anyone hear me? Okay, okay, cool. So, my name is Mohamed Fidal Saroyi. I serve as the assistant tech lead at AWS Cloud Club Unilag. Um, also a community builder for. I'm also a community builder for the serverless category. So, trust me, today is going to be like a very interesting session and also interactive. We're talking about AWS VPCs and VPC pairing. So I'm excited to have you all here, and yeah, going to be actually very incredible. So before jumping in, let me ask, how many of us have worked with AWS VPCs before, and how many have actually implemented VCP pairing, or like if this is your first time hearing about VCP pairing? Anyone? Okay. Can anyone see my slides? Okay. Okay. So our agenda for today, we're talking about what VPC is, the core components of VPC. We have the CIDR, we have the subnets, we have the security groups and the NACLs. We also have the internet gateway and the NAT gateway. And we have route tables and DNS. These are very common. So you'll be hearing a lot about them today. Then you have VPC flow logs and also the best practices and what we should always try to do when we explore these services and what they offer. Okay, so what is a VPC? VPC is like a virtual private cloud. So it's logically isolated network where you can place your AWS resources. So VPCs provide a complete control over your virtual networking environment. So your IP address, your subnet, your routing tables. So like it's a physical data center where you have everything ready now. But with this is actually more different. It's on the cloud, so there's scalability and flexibility over the infrastructure. So your VPCs can be isolated and they can be connected to other VPCs. So I can have a VPC and can be connected to other VPCs for various reasons you want to use them for. You can also connect them over the internet or link them to your on-premise network. So let's say you have a physical data center and you have the cloud infrastructure up running in the cloud. So you can connect your VPCs to your on-premise network. Okay. So here we have a diagram, or I would say how we represent VPCs in AWS. So we have the region. So your region can be anywhere really. So it can be, I think the most popular and common one is US East 1. So let's say our region is US East 1. Then in our region, we have a VPC there that's allocated to that region. So in each VPC, we have availability zones. So for this diagram and this description, we have ability to zone 1 and 2. So you can always have more than two. You can have as much as you need based on your use case. So we also have the public subnets and the private subnets. I'll be explaining more of that in coming slides. But and then one before along recently, so I can be sure. Okay, let's proceed. So I think I should do more justice to the topic. So actually know what we're talking about. So a virtual private cloud, like I said, VPC is essentially your private data center in the cloud. So you have your physical data center. You can think of that as your VPC, but you also have it on the cloud, which is your private, your which is your private data center in the cloud. So think of it this way. Um, Imagine like you have a physical building. So you actually have access to who comes in, or you have more control over who comes in, how the rooms are organized, or how people move between, let me say, the floors. Perhaps you have 2 3 floors. You can decide to know how people move around within these floors. So I'm giving you a scenario here. So a VPC gives you this level of control, but in the cloud. So some key characteristics of VPCs are logical isolation. So the VPC is completely separate from other AWS customer networks because it's private to you. So you have your own private cloud, your private network. So think of it as you only having access to that VPC. So there's complete control. So you decide everything, either the IP addresses, the subnets, the route tables. You decide how you want to divide your network into subnets, into roles or security policies. So, and it's also scalable. So I would advise people to actually try out VPCs, especially Amazon VPCs. So unlike physical data centers where the area of scalability is not really feasible, in the cloud, you can expand or modify your VPC instantly, like within 1 second or less than safe, if there's something like that. So you can expand or modify your VPC instantly without having to buy new hardware or rewire anything. So perhaps on your physical data center, imagine the hardware you have is not enough, and your boss now say you should go to computer village and try and get more hardware. So that alone is taking a lot of time. But in the cloud, you can just do this instantly without having to worry about all that. So the connectivity options in VPCs are where everything gets interesting. So your VPC can completely be isolated, like alone, or you can connect it to the internet, or you can link it to other VPCs, like I said earlier, or you can even connect it to your on-premise network. So I want you to think of a VPC like your network alone, but enterprise grade, like that kind of control and that kind of control you have over it. So let's say at home you have your Wi-Fi router that creates a private network for your devices. You can have more than one devices, but the fact that it creates a private network for your devices. So let's say your devices are your laptop, your phone, your smart TV. They all talk to each other, okay? But they're isolated from your own neighbors' devices. So your smartphone, your smart TV, your laptop, your phone, they all talk to each other, but they're not your neighbor does not have access to this network. So a VPC is something like that. So quick question for the room. What do you think happens if you launch two EC2 instances in completely separate VPCs? Like, can they communicate with each other by default? I will take the question again if anyone didn't get that. So the question is, what do you think about launching two EC2 instances in completely separate VPCs? Can they communicate with each other by default? Anyone with an answer? No one with an answer? Okay. Someone said, is there any answer? Hello? Can anyone hear
Yeah, I
me?
think yes, there is an answer
Yeah.
on the comment
Okay.
section.
Okay. What does the answer say?
Yeah, somebody said no.
Okay. No. Exactly. No. That's true. So they can't communicate. So they are in different networks completely. So that's where the VPC pairing comes in. So we'll talk about that more later. So we have to understand how VPCs are organized internally. So this is actually very important because VPC pairing depends heavily on these concepts. So cider blocks, I think we've all heard of cider blocks before. So like as the name goes in slides, classless interdomain routing. So you organize and divide your IP addresses space allocated to your VPC. So the default the default AWS VPC has something of this cider block range. So it provides over 5,536 IP addresses. So subnets are subsections within a VPC. They have cider blocks. Subnets always have cider blocks. So they're like trying to cut from the main larger cider block that the VPC is give that the VPC has its own cider block. But subnets, like I said, they are subsections within a VPC. So they are cutting from the cider block within the main VPC to have their own cider blocks. So subnets are tied to like specific availability zones and they cannot be changed without recreation. So subnets also allow you to organize, manage, and secure resources efficiently across your network. So um let me break it down more so it's actually more understandable and relatable. So don't let the name intimidate you, Sha, because I think with the name it's actually quite confusing. So it's simply a way for you to define the ranges of your IP addresses. So like the one we have here, AWS default VPC. So the slash 16 means 16 bits are fixed. So and the remaining bits can vary. So for instance, you can do trace per 16. So that's 665,536 possible IP addresses. Okay. Does anyone understand that? Okay. Let's proceed. So why does VPC peering matter? Okay. I would say because VPCs, you cannot pair VPCs that have overlapping side blocks and cider blocks. So if VPC A uses 10.000 slash 16 and VPC B also uses that same cider block, AWS has no way to route traffic between them. So there cannot be any sort of traffic between them because they have overlapping cider blocks. So it would be like you have two houses with the same address on the same street. Like even thinking about that does not make sense. So um when we talk about subnets, like I said, there are subsections within a VPC with cider blocks. So we have different types of subnets. We have private subnets, and we have public subnets, we have private subnets, and we have data subnets. So public subnets are like um, anyone can access it, like internet traffic. So private subnets are only you can access it. So it's internal. So it's only that can access it. The public is kept away from the private subnets. So we also have database subnets like extremely restricted access. So let's say you work in a company and you want only probably the CTO and the CEO to have access to let's say your application through these data subnets, the database subnets. So that's extremely restricted access. Okay. So some critical facts about subnets is that each subnet must be in one availability zone. So that's very important. And even when you're trying to create, and when we go around with the demo, you will see that you have to put a subnet in an availability zone. So the subnet CIDR blocks must be carved from the main VPC CIDR block, and you cannot change a subnet availability zone. You have to delete it and recreate it. So you have to be actually, I would say, intentional about when you create your availability zones and your subnets. So, because when you do the process, you can't delete it, you can't change it until it makes
I don't think we can't hear you.
except you delete it and create
Mohammed, we can't hear you.
again. Okay, let me give you a practical example. I want everyone on
Mohammed, can you hear me?
their notes to jot down.
Mohammed, can you hear me? Okay, just gonna. All right, guys. Just stick around and so that we can sort out this network stuff. Right. Okay. This can you go ahead, Mohammed?
Hey, can you hear me, right?
Yes, we can hear you now. Yeah. Go
Okay, okay. So, AWS VPC provides two layers of network security. So you have the security groups, which is at the instance level, and the network access control lists, which are at the subnet level. So I want you to think of the network access control list, which is at the subnet level, as like kind of your building block for your security. So let me paint a scenario here. These two, the security groups and NACLs, they are layers within, they are layers for your security. So think of it as both of them have like a security guard and individual room locks. So for the NACLs, which says they are stateless, they are the subnet level, they allow and deny rules, and they are evaluated in order. So what that means is that for stateless means they have separate rules for inbound and outbound traffic. Okay. So at the subnet level, like I said, they are like the building securities decks. Okay. So they allow and deny rules as well. So they control traffic entering and leaving the entire subnet. So when we say they are evaluated in order, what we mean is that they process rules in numerical order and stop at the first match. So it's not like out of order. So they are doing it in order. So at the security groups where we have it at the instance level, they are like individual room locks. Let's think about the scenario that I painted earlier on. So they control traffic to and from specific EC2 instances. So when you create an EC2 instance, for example, there's always an option for you to add a security group. So if you add a security group, you are trying to control traffic to and fro on these EC2 instances. As well, they are stateful. So if you allow inbound traffic, the response is automatically allowed back out. So immediately. So all the rules are evaluated before deciding to allow or deny. So it first evaluates all the rules. before it now decides, okay, should I allow or should I deny? Or rather like the NACLs, which does everything in order first. So when we set up for VPC peering, both layers need to allow traffic between the VPCs. So it's not enough to just create the connection between them. You need to update your security groups to allow traffic from the other VPC cider block. So what I'm trying to say is that for best practice, just starts with restrictive security groups. That means you are just trying to restrict as little access as possible, then gradually open up access as needed. So more like you are in a party. So when you start a party, there is no access like that based on the fact that they have to confirm if everyone is present and all that. But when people start coming, you see that the bouncer or whoever is at the door start opening the door gradually. So that kind of thing. So it's much easier to allow access than to figure out why something got compromised. Next slide. Okay. So we have the internet gateway and the NAT gateway. So the internet gateway allows resources in your VPC to connect to the internet and vice versa. So a subnet with a route to an internet gateway is a public subnet. They also have NAT gateway, which allows instances in private subnets to connect to the internet while preventing inbound connections. So NAT gateways are highly available within an availability zone, and they use elastic IP addresses for outbound traffic. So for multi availability zones like redundancy, it's best advised to deploy a NAT gateway in each availability zones with private subnets. Let's break that down. So internet gateways um like I gave the analogy of a party. So your VPC's front door to the internet. So before it gets out to the internet, it has to first check if it's one to one. Is one to one. So any subnet with a route to the internet gateway becomes a public subnet immediately. That's like a very critical thing to take note of. So resources in the public subnets can have public IP addresses and can be reached from them. So they're trying to reach they need to reach the internet, but they don't want to be reached from the internet. Like deep it, they want to reach the internet, but they don't want to be reached from the internet. Okay, so it's like more like a proxy server kind of thing. So instances in private subnets can make outbound connections. Say perhaps you have like a software update. So they can make these outbound connections, but they cannot receive inbound connections from the internet. So they are free to like it's like someone telling you like someone telling you a lot of things, but when the person wants to respond to you, the person is blocked. So imagine like you're having a play with your friend and you're just talking to your friend, then like immediately your friend wants to retaliate or talk back at you, is blocked immediately. So they have this kind of, I would say, flex where they can do everything they want outbound connections, but they cannot receive any inbound connection from the internet. I think that's very critical when it comes to like private data and maybe perhaps you don't want to expose a particular port to the internet. You don't want to expose, you don't want an incoming port from the internet. So just want to expose this particular port in the internet. So that's ways, like I said, they use
Looks like we are losing you again.
elastic IP addresses, and they are highly available within their own availability zone. So
Mohammed, can you hear me? Mohammed, can you hear me?
I think I'll talk about what we're going to do in the lab later. So let's proceed. So we've been hearing VPC network connection between two VPCs. So it allows them to route traffic using private IPC, using private IP addresses. So think of it like you have a building, like you're building a private bridge between two separate office buildings. So there's this link between these two separate office buildings, and but that link is private. So not just anyhow someone can just enter that bridge. So you need to have access. So some key characteristics of VPC peering are that there's private network traffic. So all the communication that happens over the AWS. So there's no issue of bandwidth in VPC peering. So unlike VPN connections, your normal VPN, so there's no single point of failure or like any bandwidth limitation. So one key thing to know that might actually trick people is that there's no transitive peering, like I said. So if VPC A is paired to VPC B, and if VPC B is paired to VPC C, that does not mean that VPC A can talk to VPC C. Let me repeat that. If you pair VPC A to VPC B and you pair VPC B to VPC C, does not mean that A and C can talk to each other. So each pairing is unique and direct. So it's direct and exclusive. So there are also no overlapping CIDR blocks. So if VPC A is using a CIDR block with /16 and VPC B is using a CIDR block with /16 as well, same IP address 10.000/16 for both of them. You can't pair both of them. So AWS needs unique IP ranges to route traffic properly. So also for DNS resolution, by default, DNS host names do not resolve across paired VPCs. So you need to enable DNS resolution for the pairing connection. Okay. So for an actual process of how VPC works, I think we're still going to do this in a demo, but I want you to think of this and look at it. So once you create the connection between the two VPCs, so one VPC sends a pairing request to another. So let's say the target VPC accepts that request. So when it does, you need to update the route tables. This is very critical. So you must add route tables in both VPC points to each other. Like the route tables that you must add in both VPCs, they must point to each other's CIDR blocks. So when you do that, you now update the security group to allow traffic from the paired VPC CIDR blocks from both of them. So after you do that, you can now test the communication between both of them. We'll do all this in a demo, don't worry. So many people can actually create the connection and they wonder why it does not work. So there are different reasons why it does not work. So the connection is just the authorization. You still need to tell your route tables where to send traffic to, like that is destined for the other VPCs. So just creating the connection is just basic, and that's just authorization. But you still need to do the work and tell your route tables, okay, I want to send traffic destined for this other VPC. So when to use VPC pairing versus other alternatives. Okay, so no, back to previous slide. Yes. So the best time to use VPC pairing is when you want simple direct connectivity between two VPCs. So I can say that's the whole point of VPC pairing. You want simple direct connectivity between two VPCs. You want the lowest latency possible. That means you want to serve it faster. You want to get more, want it to load faster, like we talk about in the demo as well. So when you're connecting VPCs with non-overlapping CIDR blocks, like I said, for you to have your VPC, can you hear me? Hello?
We can hear you, Mohammed.
Oh, okay. Sorry, where did I stop? Where did I stop?
You're talking about the VPC
Hello?
pairing. We're talking about VPC pairing.
Okay. Okay. Okay, no problem. So I was talking about the alternatives for the VPC pairing. Like when is the best time to use VPC pairing and when is the best time to use alternatives? So like I said, when you want simple direct connectivity between two VPCs, you can use VPC pairing. When you want the lowest latency possible as well, you use VPC pairing. And also when you are sure that you don't have any overlapping CIDR blocks and you're connecting VPCs, you also use VPC pairing. And when you don't need transit routing, so you don't need to route to like I said, the transitive pairing, you don't need let's say VPC A to talk to VPC B, then VPC B to talk to VPC C. It won't work. So let's talk about transit gateway, because there's a link between VPC pairing and transit gateway. There's a link between both of them. So next slide. Okay. So AWS Transit Gateway is a network transit hub. So it allows you to connect VPCs and on-premise networks. So like I said earlier, one of the key benefits of VPCs is that you can connect it to your on-premise network, even if you're in the cloud. So the transit gateway is a way to achieve this. So this will simplify the network architecture with like a hub and spoke model instead of complex peering connections. So the transit gateway supports transit routing between all connected networks, unlike VPC peering. So where that is very limited. So with the transit gateway, you can connect to thousands of VPCs and on-premise networks across different AWS accounts and regions. So this diagram here shows that okay, let's say we have our VPC here on premise, and this is our VPC on cloud. So it's connecting via the transit gateway. So the transit gateway provides centralized control for routing, security, and bandwidth management across your network. So exactly, let's break that down because I know a lot of people will still be confused. So um, when you have complex networking, it's best advice to use transit gateway. So transit gateway is like a central hub that will connect multiple VPCs and on-premise networks. So instead of creating multiple peering connections, which you cannot manage because it's going to be too much and it's be complex. So you can connect everything to the transit gateway. So without the transit gateway, that's when you do VPC pairing alone. Let's say perhaps four VPCs need 6 pairing connections, or 10 VPCs they need 45 pairing connections. That's a lot. But with transit gateway, any number of VPCs that you have, you just need just one connection each to the transit gateway. So transitive routing works automatically. So transit gateway supports transitive routing. Also, there's centralized management, so you're in control of everything that's happening. But for today, we're focusing on VPC pairing because it's simpler to understand and it's perfect for many real world scenarios. Next slide, please. Okay, so route tables and DNS. Like I said, this was part of our agenda. So route tables control traffic flow within and outside of your VPC. So while the Route 53 resolver provides DNS resolution services. So route tables contain routes that determine where the traffic is directed to. So um, think of it as, okay, your traffic needs to be directed somewhere, but how does it get there? You have routes for that. So each route specifies a destination, like a CIDR block and a target. So it can be the gateway or the interface. So VPC has a main route table by default. So when you create your AWS account, there's a default VPC, and in every default VPC, you have default configurations, default values. You have the default route table, default public subnets, private subnets, and all that. But you can also create your custom route tables. So it depends on your organization needs. If there's need for you to do that, you can as well do that. So, but for the DNS, Route 53 resolver is available at the .2 address of the VPC. This translates domain names to IP addresses, so enables like your resources to connect to destinations. So you don't need security groups. Security group rules are not needed for your DNS resolvers. So they don't need to access the resolver. So AWS handles this automatically. Okay, so for routing, every subnet in your VPC is associated to a route table. So that route table contains rules, which you also call routes, about where to send the traffic to. So in a default like scenario where you have a VPC CIDR block 10.0.0.0/16. So the default route table has that CIDR block, but the traffic stays within the VPC. So it's local. So let's say perhaps you pair them, you do a VPC pairing. So to enable communication with like a paired VPC, you add like the VPC connection ID, like just to let you know that okay, I want to connect to a target like another VPC. For the DNS resolution, um, like I said, for the VPC pairing, you might need to enable resolution if you want to use DNS. If you want to use DNS names across your VPCs. The next cycle. Okay, so VPC flow logs they capture information about your IP traffic going to and from network interfaces in your VPCs. So I want you to think of VPC flow logs as we have CloudWatch. CloudWatch monitors a lot in your applications, does a lot of integrations as well. So VPC flow logs is more like the monitoring part of your VPC. So it can be enabled at three levels. Okay, so you have the VPC level, the subnet level, and the network interface level. So perhaps you can publish your flow logs to Amazon CloudWatch logs, like I said, S3 or Amazon Kinesis Data Firehouse. Firehose, sorry. So it's actually useful for security analysis, troubleshooting, and compliance auditing. So like we have a short okay, I don't think it's here. I think this is wrong. Okay, let me try and visualize that. So they are like your network traffic logs, so they are essential for troubleshooting the issues you might face with VPC peering. So a sample log will tell you that you have a source and a destination IP. Then you also have the ports and the protocols. So it tells you whether traffic was accepted or rejected, like via the route table. And there's also like timestamps as well. So common issues you might face, like when you want to use your flow logs with, like when you want to troubleshoot your VPC pairing with flow logs. So for instance, the traffic can show as rejected. So you need to check either your security group, like how is traffic coming in and out, or your NACLs as well. So if the traffic does not appear at all, you can check your route table. How is your traffic structured? How are you sending out your traffic? And also, if traffic is going one way alone, you can check the return routes as well. Okay, one thing I want to talk about, just like a bonus. So VPC endpoints. So well, it's not directly related to VPC pairing, but endpoints let you connect to AWS services privately. So it's actually very useful in paired architectures where you want to avoid internet traffic. So they allow you to connect to privately to other AWS services. So the traffic between your VPC and your AWS services stays within a network and does not go over the public internet. So you also have gateway endpoints. your NAT gateway or your um, transit gateway. So they support AWS S3 and DynamoDB using route tables to direct traffic. So your internet interface endpoints is powered by AWS Private Link. So it supports many other AWS services using private IP addresses. So if you want to add security by restricting access to AWS services from private subnets without the internet, you should use VPC endpoints. So this diagram shows that we have the gateway endpoint here, we have the internet interface endpoints using AWS Private Link. You also have the AWS network with DynamoDB. So you have your VPC, you have a private subnet, but inside your private subnet, you have your EC2 instance. So that EC2 instance does not allow access to the public internet, but can communicate internally. So what your endpoint does is to privately connect to your VPC, then to supported AWS services that you are connecting it with without actually using an internet gateway. Next slide. Okay. Some best practices for your VPCs is to you need to plan before you actually start allocating maybe your CIDR blocks or your route tables. You need to plan your IP addressing with future growth in mind. So, in as much as you're starting, don't allocate the least possible CIDR blocks. Allocate as much as possible because you might never can tell what your application is going to scale.
I'm not sure I can hear you, Mohammed. Mohammed, if
So
you're speaking, okay.
also use private subnets for backend resources. I think it's quite normal that whatever you're building, the so always use private subnets for implement security in layers, like we talked about. Also create separate route tables for different subnet types. I think that's important. So as to flow logs for security and VPC peering. Peering, I forgot to mention, has data transfer charges. So especially when you're doing cross region. So it has data transfer charges. So expect cost from that. Okay, so also use flow logs. So enable them before you actually troubleshoot. That's better. And automate with infrastructure as code as much as possible. So it's actually easier for you to clear your resources, your VPC resources immediately and maybe spin it up again. And also regular security reviews. Ensure that you actually check your security groups maybe once in a while, and the rules as well. Is what's the inbound traffic looking like, what the outbound traffic looking like, and for your NACLs as well, make sure you check them too. Thank you. So we'll move on to the lab, but just to confirm, is everyone on the same page? Are we all on the same page? Um, then you respond.
Yeah, yeah, they are on the same page with you. Can go ahead.
Hello?
You can go ahead, Mohammed. They are on the same page with you. Can you hear me?
Is there any response?
Yes, yes, yes. You can go ahead. Or
Hello? I can't hear anything. Can anyone hear me?
we can hear you. Can you hear me? I think you are the one that cannot hear us. We can hear you. Okay.
Hello.
We can hear you, Mohammed.
Okay, okay. I was asking if there was any response from the audience. Considering what we've
That,
done.
they
So
said
before
that
we move into
they
the
said
lab.
you can go ahead, please.
Okay, okay. So we'll go ahead with the lab shortly. So let me get that done. Okay. Can you see my screen? Can you see my screen?
Yeah, I can see your screen. Just hold on.
Okay.
Uh, okay.
Okay. Before we get started, this is what like your VPC blocks look like. You have AWS, like I said, if you are looking for your VPC, just come here, then check for your VPC. So we're currently there right now. Okay, let's load that again just to be sure. So what we're going to be doing, trying to do like a lab for the VPC pairing setup from scratch. So by the end of this lab, we should have two isolated VPCs with different CIDR blocks. So EC2 instances running in private subnet and a working demo of how the VPC pairing connections happen and with like proper routing as well. So I don't know if there's a way I can actually let me try and draw. So actually much better. That's great. Can you see my screen? Okay. Can you see my screen? Can you see my screen?
I can see your screen.
Okay. Okay. So uh, okay. I want to draw like a little short diagram so we actually get what we're trying to do here. So it's not be like as if we're um hallucinating. I'll say that. Can you see this? Okay. So we'll have a VPC here. VPC A. Then Yes, I'm trying to draw the diagram of what we're trying to do here. So it's actually much better to understand and follow along as well. Okay. Okay. Let's make this 10. So it's better. Okay, I think, yeah. Better. Like I said, when you're trying to do a VPC pairing, you should ensure that the cider blocks are not the same, so they don't overlap, unless it won't work. So let's change that. And also for the EC2 instance, you need to change that as well. Okay, so um, there's like a sort of pairing. Okay. Let's check this. Okay. Are we on the same page here? Can anyone see this?
Yep, we can see.
Can you see this?
We can see it, Mohammed.
Okay. Um, so if you're following along in this lab, I want you to open your console, check your check your ensure that you're in the correct region. So for this, you're using US East one. It's quite popular, and I think it's best suited for this demo. So ensure that you can see the VPC in your console as well, and you have the permissions to create an EC2 instance. I do. So I want you guys to ensure that you all have this as well. Okay, so if anyone is having issues, probably anyone is having issues setting up, just take a look at this demo and you see how it's going to be implemented here. So for the very first thing, I think we've done all that. So let's create a VPC. So right here. So there's this new feature from AWS where you can preview your VPC. So when you create a VPC, you have um a view of everything before you even actually finish it. So the subnets, the route tables, the network connections as well that we talked about. So for this, we want only VPC alone. So for the name tag, I think I said it's quite important that we name our VPCs. So this is VPC Lab A. So the cider block we're using 1016. I think I can get that from here. Okay. So like here the description says the cider block must be between the /16 and /24 and /28. Sorry. So you can do 24 if you want to as well. So we're not using IPv6 cider block, not yet. Our use case is actually very simple. So we'll go ahead and create a VPC. So now that we've created this VPC, you can see the VPC ID here. It's quite important. So you go down, then let's create a subnet as well. Okay, so we have your subnets here, and let's create a subnet. So for the subnets, like we explained earlier, you have to route it to a VPC. So we have our default VPC. We have our VPC lab A that we created earlier on. So for the subnets, we are using this. So like I said, there should not be any overlapping VPC. So for this, we are going to use this. One of our subnets, you can think of it. A very creative name. Oh, sorry. I think let's create two VPCs first, so it doesn't become confusing. So we have our VPC in here. Um, let's create VPC B, lab B. Yeah. Okay. Cider block is different from the previous one. The previous one only had 0 here, but we're changing that to 1. So there should not be any overlapping because of our VPC pairing. We need to ensure that they are quite different and there should be connection between both of them. So we have our two VPCs ready. This is for lab B. We initially created lab A, so we have both of them here. Okay. So after we've done that, let's create the subnets for each one of them. So we create a subnet for the first one, which is lab A, our first VPC. Then you can give it a name like subnets lab A. I think that's quite better. Subnets lab A private. Okay, private. Okay, subnet A lab A private. No, I think naming is wrong. Okay. Okay, lab A private. So availability zones, I said, is it's quite important that you put your subnet in an availability zone. So for that, we can use anyone. I think let's use US is 1A. That's quite simple. For the VIP cider block as well, you can use anyone as well. So I think for this, we should use the /24. Let's be different this time. Okay. Um, this is for the VPC, like I said earlier. So where the subnet cider block gets its own cider block from the VPC cider block. So it pulls from that. So you can use 10.0 /24. Okay. So let's create our subnets. So for our first VPC, we already have a subnet of for it already. So let's create the second subnet, but for this time for lab B. Okay, let's give it a name as well. Subnets lab B private. Okay, US East one as well. I think that's quite important. Then 10.1.0 24. Okay. Yes, let's create our subnet. So now we have two subnets. So let's take a pause currently and see what we've done so far. Trying to see what step okay. We want it to be a private subnet. I have the like a subnet as well. So
I think
like
we're
we've
losing
done
you again.
so far, we've done two VPCs. So we've done like
All right, guys. Looks like we lost our trainer. Um, okay. I believe you all learned some couple of things. If you can hear me, can you probably just drop an emoji or something on the comment section? I want to be sure that you guys are here. Um, do you have any questions? I mean, people are not saying anything. Can you guys hear me?
I didn't hear a question
If
earlier.
you,
Sorry. What was your question
we
earlier?
lost you. We lost you,
Oh,
Mohammed.
okay.
There was no question. We lost you. Uh,
Okay. Sorry for that. So, like I said earlier, we've created two VPCs. The first one is here. So we have our VPC A here. Then this is it right here. So we have the VPC ID, the CIDR block range. Take note of that. It's 10.000/16. We also have for B, which is 10.1. So it's different this time. And we also have the CIDR block range as well. So for these VPCs, we created subnets. So each subnet for each VPC. So for this case, we had subnets for lab E, which are going to make a private subnet. So we have the CIDR block here, /24. So we're picking our CIDR block from this VPC CIDR block for lab E. Then also for lab B, let's scroll down and check. Okay, yeah. So lab B as well, we have our CIDR block range and our subnet as well. So what we are going to do now is try to create EC2 instances that will enable the VPC peering connections. So let's go ahead and do that. So go to EC2. EC2 is like a virtual server in cloud. I think that's the explanation is quite it's quite explanatory about it. Okay, so let's create instances loading. So give it a while to come up. Okay, that's done. So we're going to launch an instance. You can name it instance VPCA. Image type, I think we'll keep it to the barest minimum. We're going to use an Amazon 2023 AMI. That's quite normal and common. So just run into part of. So we have the network, the VPC, what is it connected to, the subnets as well. So for this, we're going to edit it and we're going to make a lot of changes here. So for this, we're going to use the VPC lab A because this is an instance type for lab A alone. So for these subnets, we also have the subnet, the private subnets that we created for lab A. I'm going to use that as well. Then we're going to disable auto sign public IP. I think this is very important as well. So the firewall, I'm going to create a new security group. So let's give it a unique name, SG Lab A. Okay, so um, let's give it a unique description as well. Allow allow ICMMP and SSH. So those are like ways to connect to your EC2 instances. So our security groups, where do you want to route the traffic, like the inbound traffic? What do we want exactly? So we have SSH, which is port 22, and also we're going to create a custom one. So we said for ICMMP and SSH. So we already have one for SSH. Now let's create the one for ICMMP. So custom. Yeah, this should be custom. So ICMP is custom. So the source will be 10 points. Okay. We want from a specific CIDR block range. So let's use this. Okay. So this will ping it directly from VPCB. So um, it's quite important to note that the security group, the second rule, that means this one we are doing now, is for the VPC, is for the VPC B CIDR block. So if you go back and you check, this is VPCB here. So the CIDR block is 10.1.0.16. So we are trying to ensure that there's network traffic for that CIDR block. So there will be communication, like inbound traffic. So this is like you thinking ahead when you want to set up your peering. So we'll go ahead and launch the instance. So you can also see a summary of what you've done here. AWS has made it so easy for you to do. Okay, I don't need a key name. Proceed with that keep here. We're not doing that for now. So it's going ahead to create VPCA, which will do that shortly. Okay, what's the error? I think there's an error here. Okay, okay, I see. Okay, ping for VPCB. Let's see any if there's any network configurations we need to do. I'm getting an error here, so I'm trying to see what's up. I think that's everything is good. Okay, let's proceed. Oh, I'm still getting an error. I wonder why. Let's see. It's failing to create the security groups. Okay. Um, security groups. Let's edit. Okay. Oh, the source type. This is the first security group. Oh, I made a mistake here. So it's meant to come from there. Then the source. There are two rows. So I was doing everything in one row instead of the first one. So that was kind of my bad. So let's change that and ensure this is only for the first row. So this comes from SSH anyway here. So this custom TMP. Yes. Custom ICMP 346. Okay. So 10.66. Okay. We'll try this shortly. Just let me review and see if everything is good. Okay, port 22 anywhere. 0.00. Okay. Let me copy the same description. So I'm right on track. So this. Okay. Still failed. What's going on? Okay. Um it's anywhere. Yes. There's another row. Okay, there's not any issues. So that's actually better. Still the same. Okay. Okay. You don't need this for now. Let's just add a basic rule. Let's just use the first one, which is allow from anywhere. Custom TCP, yes, SSH. I think this failing at the second one where we talked about adding ICMP. Anyway, yes. Oh, still failing. Okay. Um, let's see. Instance VPCE. We have, yes, we're selecting this. Okay. Okay, this is good. Let's proceed. We don't need the queue. We don't need the keep here for now. So leave that as it is. And edit this. We're going to use VPCE. Yeah, we're going to use the private subnet as well. So we're creating a security group, like I said, SG lab A, allow ICMP and ACP, allow ICMP and SSH. So for the first rule, we're going to use SSH from anywhere, which you've done already. So we add another security group role. I hope this time it works. Fingers crossed. Uh, Custom here should be custom as well. Custom ICP IP4. I think that's quite important. Yes, all. Um, yeah, sources or BPC nets. VPCB. That's where our source is from. So this should work. Wow. Let's diagonalize with Amazon Q. This is quite an issue. Okay, so one thing to note is that when you run into errors like this or issues like this, you should always try to stay calm and see how you can resolve this. But there's this offering by AWS, which is Amazon Q, which helps it understand the cloud context. So if you ever run into issues in your terminal or your console, you should always try and leverage Amazon Q. So it gives you and diagonalizes the errors that you might face in your console. So it can be related to anything. But currently we have an issue related to the VPC, the instance, when you're creating the instance. So we wait for the feedback from Amazon Q. Okay, that's fair to load. That's strange.
Now, can you hear me?
Yeah, I can hear you.
Okay. It could be from the probably the route table. The VPC currently does it allow network in?
Yeah. No,
Um,
no.
so
I'm trying to launch an instance. So I created the VPC. Like so I'm trying to like allocate the VPC that I created with its subnet. So there's not really much of the route tables because I've not actually specified where I want my traffic to go to yet. So it's just like basic connections for my security groups. I want
okay,
this so ports and what do you say?
can you create the instance on the default VPC so they can see what's going on?
Oh,
So they
without the
can
security
know.
groups.
Can you create the subnet you're using is on the
Yeah,
is from the new
it's from
VPC
the
that you
VPC.
created
Yeah,
right?
Yeah.
So I'm saying that can you launch a new instance on the default VPC?
Okay. Let's try and do that first. I think that should work. Okay. Let's instance. Okay. Let's try and use the defaults and see if it works. Okay. Let's see if it works first. Oh, it did. Wow. So we still have to like manually edit our security group settings. But like the first instance has been created. So let's proceed to create the second one as well. So we can have two instances launched. So the first one we have instance VPCA. So let's do instance VPCB as well with our default VPCs and subnets. So when we do that, then we can now go into the settings and change it to what we specifically need. Okay, we don't need a these are our second instance they are trying to work with. Um, okay, so go ahead and create as well. I'll launch the instance. Okay, so these two should spin up. So when they both spin up, we now have to make adjustments to our security groups. Okay, so by now we should have our two instances up and running. Okay, they're still initializing, so it's take a little time. Let's say like a minute or two if we are lucky. So once that is going on, we need to create security groups. So under the EC2 page, we have the the security groups we can find easily. So let's go ahead and do that. So we're creating two security groups here. One for the first instance. So we call this SG Lab A. So description for this is that we want we're going to use our VPC Lab A. So for this, we want a role that the inbound role should be that from SSH. Okay. So we want traffic from that part. So from the port range, which is 22, 0.0. Yeah. So this should be for the session manager. And we also want outbound traffic, but this one should be custom. So custom ICMP. So this should be for all ICMP IPv4. So this should route to our VPCB CIDR block, which is this. So this is for ping from VPCB. So let's go ahead and create that first. So it's quite important to know that the second rule is allowing ping from VPCB, so which is our VPCB CIDR block. Okay, so let's go ahead and create that as well. Okay, description allow ICMP and SSH. I think this was one of the issues we had. So it could not begin with this. So I'm trying to make it unique. Okay, let's make it unique. Security group lab A. Let's copy the name so I have a lot of time to. Okay, so we created our security group, the first security group, inbound traffic SSH, port range 22, and outbound traffic for this as well. So it's quite important that you give your rules, descriptions, or you tag your resources for better readability. Because you can be working in a team and the person that's working with you wants a way to actually understand what you're doing. So it's quite important to do this. So for this, we're going to be creating the security group for lab B. So for this, we're trying to are we trying to allow access? No, same thing as well. Allow ICMP and SSH. So we're going to use the VPCB VPC. So for inbound rule, we're also going to allow SSH from anywhere as well. So use SSH anywhere. Yes. Then for our outbound rules, ICMP as well. Okay. No. Custom. 10 points. Yes. So this is pinging from VPCA. You know, the previous one we did was pinging from VPCB. Let me show you guys quickly. So this is the security group for VPCB. The one we did earlier was for security group for the VPCB. So what that did was that when we created the security group, we allowed an outbound rule that will ping to directly ping from VPCB. So it takes the subnet group of that. Let me show you guys that. So yes, it's loading. Okay, yes. So this is it here. So it pings from that one. Okay. VPCB says. Okay, VPCB says 10 points. Okay, yes. So this one is 1. It's meant to be 1 as well. So let's make a change to this. Okay, yes. Yes. So the A is pinging from the B now with the correct slider block. So when we are creating for VPCB, we want to ping from A. So A is this as well. So ping from VPCA. Okay, let's go ahead and create that as well. So by the time we go back, both our instances should be launched. So when they are both launched, we should try and attach these security groups to them. So let's see if they are running. Okay, fine. Yeah, both of them are running. So let's make edits to them. Start settings. Okay. Security. Yeah, change security groups. So I'm going to use okay, let's remove this and use security group A. I think they should be created by now. No, I not this too. Yes, this is what I need. This one. Okay. Should be loading here, but I don't know why. Let's try and terminate the instance first. Stop.
Mr. Mohammed, we are running out of time.
So we have to first stop the instance to see if our security groups.
Hope you can hear me, Mr. Mohammed.
Yeah, I can hear you.
I said we are running out of time.
Hello?
So we are
Oh
running out
yeah.
of time.
I'm trying to get the security groups. I'm trying to get the security groups. But it's not here. Let's search for it. Okay. Okay, let's first stop this and see if it works. Okay, it's taking a bit long to fetch our security groups. I don't know why exactly. It should be did that. Okay, that been stopped. So let's see if we can modify this. It's not showing. Let's see. Okay. Let's see if we can check it out from when we are creating a new instance. Because it's meant to show like when changing. Okay, let's see. It's loading. Okay. Select an existing security group. Oh, not showing as well. Okay.
Are you on the same region? Why is it not showing?
Yeah, I'm in the same region. Exactly. I don't know, it's not showing.
Okay.
It's meant to show I'm in the same region. Okay. Uh, let's see if we can edit this. Shared security group. No.
I feel like the this session is too competent. Like the we spent so much time. Uh,
Yeah.
so if you are on the if you are here and you have any questions, right? This you can drop it. Um,
What do you say?
no, not you. I'm talking to the community. So if you are here and you have some
Okay.
questions that you would like to ask or clarifications on something, you can drop the comments. Um, we can have another session on this networking. You can say maybe um, the workshop, just the workshop alone, and not the theory parts. I think uh, this part needs to be looked into again.
Okay. Let's see.
Okay, looks like nobody's saying anything. Not even sure if some of these guys are here trying to. Uh, so Mohammed, I think
Wait.
can end
Okay.
can end the call. So what we'll do is we have another session later on. We'll talk about networking, like let's say lab. So it's not going to be theory, just lab. Uh, we can properly do this properly. Like we do it based on uh, manual process and also ISC. So which is going to make things much
Yeah.
easier and more fun. Yeah. But for today, I think we should spend so much time. Yeah.
Okay. Are there any questions?
Yeah. No questions. So no questions.
Okay.
Yeah. Just stay behind, okay? So have fun.
Okay.
All right, everyone. Thank you so much for joining to this call. I believe you guys have learned some few things. Networking is very broad, like it's very broad, and it has a lot of complexities that surrounds it. Um, yeah, and I'm very sure that the basis has been covered in terms of definitions. What is peering? You learn about peering, you learn about VPC, the route table, um, you learn about the IP gateways, the IP address, security groups, NACLs. And some of the things are what you need to understand the networking. So go back again to watch the video, understand the story. So we are going to have another session on networking. It's going to be hands-on networking. All right. So thank you for joining. We'll see you again. And if you have any question, you can drop it on the group. We will answer you. Thank you. Uh, okay.